Okay, greetings one and all, and welcome to this mathematics video. In this mathematics video, we'll be considering a Bgcse mathematics past paper. The year is 2021, paper 2. Let's consider it. Here we have Bgcse, Ministry of Education, National Exams, Mathematics Paper 2, June 2021. So we're going to be looking at the past papers. We're going to be looking at the past questions that were given on the 2021 Bgcse past examination. Let's begin. Number one says the temperature in Canada at 5 p.m. is -6 degrees Celsius. It falls by 10 degrees Celsius and warms by 20 degrees Celsius at 10 a.m. Find the temperature at 11 a.m. Notice that it says that the temperature at 5 p.m. is -6 degrees. So let's put that there. It falls. So because it falls by 10, we're going to put -10, and it warms by 20 degrees. So it warms by 20 degrees. So we're going to say +20. So it was at -5. It fell, or it falls by -10, and it warms up by 20. So we're going to put +20. And so our numerical expression that we have to evaluate here is going to be -6 minus 10 plus 20. -6 minus 10 is going to be -16 plus 20. We bring that down. And a -16 plus 20 is going to be +4. And so the temperature at 11 a.m. is going to be 4 degrees Celsius. Let's move on to question number 2. It says Eric buys three crack cone snacks at $14.50 each, and 2 cone salads at $12 each. Calculate the total cost. If you want to figure out the total cost is going to be 3 times $14.50 plus 2 times $12. What is 3 times $14.50? Well, 3 times $14.50 is $43.50, and 2 times 12 is going to be $24. $43.50 plus $24 is going to be $67.50, and so that means that the total cost for his 3 crack cones and 2 cone salads is going to be $67.50. Let's move on to the next question. It says Eric buys three crack cone snacks at $14.50 and 2 cone salads at $12 each. VAT, or value added tax, at 12% is added to the total. Calculate the amount due for VAT. Notice that VAT is 12% of the total. What is the total? The total is $67.50. And so we're going to say 12 over 100 multiplied by $67.50 over 1. 12 times $67.50 is definitely 810, and 100 times 1 is going to be 100. And so we have 810 divided by 100, which is going to be $8.10. Let's move on to the next question. Now we have Eric total bill. So the total bill is going to be the amount, the total bill is going to be the total amount plus the VAT added. Okay, so the total bill is going to be the total amount that we found earlier, plus the value added tax, which is $67.50 plus $8.10, and we get $75.60. How Eric pays, the next question says that Eric pays with two $50 notes. How much change did he receive? To determine how many change did he receive, we have to subtract. So we have 2 times 50, because that's two $50 notes, minus $75.60. 2 times 50 is definitely 100, minus $75.60, and we subtract these two, and we get $24.40. And that's going to be the amount of change that he received. The next question says, write the following in standard form or scientific notation. Here we have 7,564,000,000,000, and we have to convert it into scientific notation. We're going to start off with our decimal point here, and we're going to move it over all the way here in between the 7 and the 5. We're going to move it over. Let's count how many times that we move it over. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we move it over 12 times. And since we move it over 12 times, it's going to be 10 to the power of 12. And it's positive 12 because we move it over 12 times to the left. All right. And so we have 7.564. We dropped all of these zeros. We only include the non-zero digits. So we have 7.564 times 10 to the power of 12. And that's our answer for this question. Next up, we have 0.00000918, and we have to figure out what is this number in scientific notation or standard form. But what we need to do is we need to move the decimal point over to the right-hand side. And so we have 1, 2, 3, 4, 5, right? We move it over 5 times. And so that means we have 9.8. Now, because we move it over 5 times, we have it to the power of 5. But because we move it over 5 times to the right, it's going to be negative 5. So we have 9.18 times 10 to the power of negative 5. Our next question says that Jupiter has a volume of approximately 1.43 times 10 to the 15 kilometers cubed. The volume of Neptune is approximately 6.25 times 10 to the 13 kilometers cubed. How many times bigger is Jupiter than Neptune? Give your answer in standard form. So here, what they want us to do is they want us to actually divide these two numbers that are written in scientific notation. So we have the bigger volume, which we're going to put on top, 1.43 times 10 to the 15. We have the smaller volume at the bottom, 6.25 times 10 to the power of 13. Now, how do we divide these two numbers? Well, we're going to divide it in the following way. The numbers that are decimal numbers, we're going to put them together. The numbers that are base 10, we're going to put them together. We're going to group them together. And we just divide. So 1.43 divided by 6.25 is going to be 0.2288. 0.2288, and then 10 to the power of 15 divided by 10 to the power of 13. Notice that these two numbers are base 10, and when we're dealing with two numbers that are base 10 and we are dividing them, all we need to do is subtract the powers. And so we have 15 minus 13. So we have 10 to the power of 15 minus 13, which is going to be 2. And here we have 0.2288 times 10 to the power of 2. But this is not in scientific notation yet. What we have to do is we have to move over this decimal point. We have to move it over to the right-hand side to get 2.288 times 10 to the power of negative 1. When we move it over to the right, because we move it over to the right, we put negative 1. Sorry, when we move it to the right, we put the negative sign. And because we move it over once, we're only going to put 1. So it's 10 to the power of negative 1. And so we have 2.288 times 10 to the power of negative 1 times 10 squared. We couldn't leave this number as such because it wouldn't be in scientific notation. For scientific notation to work, this number has to be a number between 1 and 10, inclusive of 1. All right. And so it could be a number between 1 and 10 where 1 can be included. So this number is definitely between 1 and 10. And so, sorry, this number is not between 1 and 10, but this number right here, 2.288, is between 1 and 10. And so we know we have it in scientific notation right here, this particular part. But we're not done thoroughly because we still have to deal with the base 10s, right? And so when we have 10 to the power of negative 10 times 10 times 10 squared, how are we going to deal with it? Notice here that we are multiplying. So because we are multiplying and we have two numbers that are base 10, when you're multiplying and you have two numbers that are base 10, you're going to add the powers. And so we have 2.288 times 10 to the power of negative 1 plus 2. A negative 1 plus 2 is definitely just going to be 1. So you have 2.2. So yeah, sorry, we have 2.288 times 10 to the power of 1. And that's going to give us 2.288 times 10. Now, this is definitely in scientific notation because this number right here is between 1 and 10. And this number is base 10. And it's definitely to the power of 1. Even though we don't write to the power of 1, because 10 to the power of 1 is still 10. And so this is in scientific notation. Now, this is in scientific notation, and this was not in scientific notation because this number right here was not between 1 and 10. So what we had to do is we had to make sure, convert this number to a number between 1 and 10 so that it can be in scientific notation. Okay, let's move on to the next question. Here we have to solve this inequality. The inequality that we have is 8m minus 7 is greater than or equal to 5m plus 14. What we're going to do is we're going to send over the 5m to the left-hand side. And so we have, and then what we're also going to do is we're going to send over the negative 7. So we have negative 7 going to move over to the right-hand side. So two things are happening. The 5m is going to move over to the left-hand side, and the negative 7 is going to move over to the right-hand side. And so we have 8m minus 5m is greater than or equal to 14 plus 7. It was a positive here. When we send it over the inequality sign, it becomes a negative. This was a negative. When we send it over, it becomes a positive. And so 8m minus 5m is definitely 3m. And so we have 3m is greater than or equal to 21. Why 21? Because 14 plus 7 is 21. Now we're going to divide both sides by 3. And 3 divided by 3 is definitely going to be 1. So we cancel out these two 3's. And so we are left with m is greater than or equal to 21 over 3. And 21 divided by 3 is definitely 7. And so we have m is greater than or equal to 7. How do we represent that on a number line? Because the question part B says, show your solution to A on a number line. So here we construct a number line from negative 10 to 10. Wherever we see 7, we're going to put a circle above 7, all right? But it's going to be a shaded circle. It's going to be a shaded circle because we have this line, right here. And this line means that 7 is included. So we have the shade in 7. Now, m is greater than 7 as well, though. So that means we have to include the numbers that are greater than 7. And numbers that are greater than 7 are going to be 8, 9, 10, 11, and so on. And so we're going to put our arrow to the right. And so this is m is greater than or equal to 7 represented on a number line. Now let's move over to the next question. Here we have question number 5. It says a man's basic wage for a 40-hour work week is $38.40 per hour. Calculate his weekly wage. So if we want to figure his weekly wage, we need to multiply the number of hours that he worked, right? Multiplied by how much he get paid per hour. And so it's going to be 40 multiplied by 38.40. And 40 multiplied by 38.40 is definitely going to be 1,536. That's going to be his weekly wage, 1,536. Now let's move on to the next question. It says that overtime is paid at time and a half. Calculate his pay for 1 hour of overtime. If we want to figure this pay for 1 hour overtime, we have to take in his hourly rate and multiply it by 1.5. Why 1.5? It's 1.5 because they said time and a half. And time and a half means 1.5, means that we have to multiply by 1.5. If they said double time, then we'd have to multiply by 2. But because they said time and a half, we're going to multiply it by 1.5. And so we have 1.5 multiplied by 38.40. And so 1.5 multiplied by 38.40 is going to be 57.60. So 1 hour overtime is going to be 57.60. And that's how we're going to get how much he is paid for 1 hour of overtime, right? That's the amount that he is paid for 1 hour of overtime. Okay, let's move on. Calculate his total wage for a week when he works 58 hours. His total wage for a week when he works 58 hours. In order to do that, what we need to do is first figure out the number of overtime hours that he worked. And we're going to do that by subtracting 58 by 40. 40 because his regular workday week requires him to work 40 hours. And so we're going to subtract 58 and 40, which is going to give us 18 hours, which means that he worked 18 hours overtime. Okay. Now we're gonna figure out how much money he got from the 18 hours overtime that he worked. We're gonna say 18 multiplied by the hourly rate that he's paid for 1 hour of overtime. And so 18 times 57.60 is going to give us $1,036.80. And so we have right here his overtime pay. Now we need to add that to his, basic weekly pay to figure out the total wage for the week. So the total wage for the week is going to be equal to the basic weekly pay, which is going to be 1,536, which we calculated earlier, plus the $1,036.80. We add these two together and we get $2,572.80. Next, we have to figure out, for this question, we have to figure out the length of the zip line. It says Sami makes a zip line run in 45 seconds at an average speed of 17.6 meters per second. Calculate the length of the zip line. Now for this one, notice carefully what they gave us, right? They gave us the speed and they gave us the time. And so they want us to find out the length or the distance. So we have to use our speed, distance, time triangle. Speed, distance, time triangle. And notice here that speed, right? Speed is going to be equal to what? Distance divided by time. Speed is going to be equal to distance divided by time. And so that means that if we're trying to figure out the distance or the length is going to be what? Speed multiplied by time, okay? Speed multiplied by time. And so the formula is distance is going to be equal to what? Speed multiplied by time. What is the length of the zip line? We're going to take the speed and we're going to multiply it by the time. What is the speed? The speed is 17.6 meters per second. And what is the time? The time is going to be 45 seconds. So 17.6 meters per second multiplied by 45 seconds. When we multiply them together, we get 792 meters. So the length of the zip line is going to be 492 meters. Okay, let's move on to the next question. Here we have, for question number 7, it says, at a time when the exchange rate of US currency to Guyanese currency is $1 to 208.65 cents in Guyanese, Sherelle converts $500 to Guyanese. How much money does she receive in Guyanese? Well, in order to figure out the amount of money that she receives in Guyanese, we know that $1 is going to be equal to $208.65 in Guyanese. And so we need to take our amount that we got for our US and multiply that by $208.65, which is going to be equal to 104,325. And so that's the amount of money that she received in Guyanese. Let's move on to the next question. It says, Cheryl spends $77,617.80 and converts the remaining amount to US. How much money does she receive in US? So first, we got to take away, we got to subtract this amount of money from the $104,000 and $104,325, right? So you have to subtract those two numbers to get the amount of money that she has remaining in Guyanese. And so that's going to be equal to $26,707.20. That's the amount of money that she has remaining after she does her spending. And then what we're going to do is we're going to convert this $26,707.20. We're going to convert it back to US. And we're going to do that by dividing by $208.65. And when we divide these two numbers, we get $128. So that means that the amount of money that she received in US is going to be $128. Okay, the next question says, if x is equal to 3 and y is equal to -5 and z is equal to 9, find the value of 6x squared minus 9y all over z. Here, x is equal to 3, so wherever we see x, we're going to put 3. Here, y is equal to -5, so wherever we see wherever we see y, we're going to put -5. And here, z is equal to 9, so wherever we see 9, wherever we see z, we're going to put 9. And so, if we substitute, again, wherever we see x, we put 3, so we put 3 here. Wherever we see y, we put -5, so we put -5 here. And where we see z, we put 9, so we put 9 right here. And so what we have to do is we have to simplify at the top, right? So we have 3 squared. 3 squared is going to be 3 times 3, which is 9. And so we have to multiply 6 times 9. 6 times 9. And then after that, after we multiply 6 times 9, we're gonna do in our calculator -9 times -5. So we have 6 times 9 minus 9 times 5. We put that all inside our calculator. 6 times 9 minus 9 times 5, which is going to be equal to 99. If you put it all inside a calculator, all over 9, right? So 99 divided by 9 is definitely going to be 11. And so our answer to this question is going to be 11. Moving on to the next question. Here we have 5a all over 6 plus a over 9. In order to add these two fractions, what we need to do is we need to find the LCM of 6 and 9. So we have to make the denominators the same. We cannot add them because the denominators are not the same. So we have to make the denominators the same first, then we can add them. What are the multiples of 6? 6, 12, 18, 24, and so on. What are the multiples of 9? 9, 18, 27, and so on. And so that means that we're going to find the LCM by noticing that 18 is here and 18 is also here. And so that means that the LCM of 6 and 9 is going to be 18. And so we ask ourselves, what times 6 gives us 18? Well, 6 times 3 is 18. And what times 9 is 18? Well, 9 times 2 is 18. So whatever we do to the bottom, we must do to the top. 6 times 3, we multiply that one by 3. We have to multiply 5a by 3. 9 times 2, we have to multiply 8 times 2. And so we have 6a multiplied by 3, which is going to be 18, and 5a. Sorry, we have 6 times 3, which is going to be 18, and 5a times 3, which is going to be 15a. And then we have 9 times 2, which is going to be 18, and then 8 times 2, which is going to be 2a. And so We have 15a plus 2a, which is going to be equal to 17a, and we just have the 18 at the bottom. Moving on to the next question. Here we have a simultaneous equation. It says solve the following pair of simultaneous equation. Show all working to support your answer. Here we have 2x plus y is equal to 18, and we have 3y minus 4x is equal to -1. We're going to call the first one equation 1, and we're going to call the second one equation 2. Now, our first step is that we're going to make y the subject of equation 1. So here we have equation 1, and we're going to make y the subject, which means that we're going to send this 2x over the equal sign. So we're going to send it over the equal sign, and so we have that y is equal to 18 minus 2x. It was a positive here, but when we send it over the equal sign, it becomes a negative 2x, and we're going to call this equation 3. I'm going to call this equation 3. Now we're going to take equation 3 and substitute it into equation 2 and solve for x. Now, what is equation 3? Well, equation 3 is this one, which we just determined. And we're going to put our expression for y into this equation, right? Into this y right here. So we're going to take what we know y is, which is 18 minus 2x. We're going to take that and we're going to put it right here. We're going to substitute it in. And so we have 3y minus 4x is equal to -1. We're going to put in 18 minus 2x, right? Because we substituted our equation 3 into equation 2. So we substituted our value for y, right? So we have y is equal to 18. Sorry, we know that y is equal to 18 minus 2x. And so instead of putting y again, we're going to put 18 minus 2x because that's what y is. Now we're going to distribute 3 times 18 and 3 times 2x. 3 times 18 is 54, and 3 times 2x is -6. And so we have 54 minus 6x minus 4x is equal to -1. What we're going to do is we're going to consider -6x and -4x. That's going to give us -10x. Then we're going to send the 54 over the equal sign. That's going to be -10x minus 1 minus 54. And so -10x is equal to -55. We divide both top and bottom. Sorry, we divide both sides rather by -10. This is going to cancel out. These two are going to cancel. So we are left with x is equal to -55 divided by -10. And so that means that x is going to be equal to 5.5. Seeing that we already know the value of x, we're going to take the value of x and substitute it into equation 3. And equation 3 is y is equal to 18 minus 2x. And so we have y is equal to 18 minus 2x. And so wherever we see x, we're going to put 5.5. And so y is going to be equal to 18 minus 2 times 5.5. 2 times 5.5 is going to be 11. And so that means that we have y is going to be equal to 18 minus 11. 18 minus 11 is going to be 7. And so we have that x is equal to x is equal to 5.5 and y is equal to 7. And so our answer is x is equal to 5.5 and y is equal to 7. Let's move on to question 9. For question 9, we have this triangle. And what they want us to do, well, we have not just one triangle here, but let's consider the triangle that has x in it. So you have this triangle right here that has x in it. This is x. And if you notice that this is definitely what we call an isosceles triangle. Why? Because this side and this side are equal. Now, how do we know that these sides are equal? Because of these two lines. These two lines on both sides tells us that, hey, this line and this line are equal. They're equal in measure. And so we're dealing with an isosceles triangle. And since we're dealing with an isosceles triangle, the two sides are equal and the two angles are equal. That means that if that side is x, this side is also x. So these two angles are going to be equal. And so we have, in order to figure out the value of x, what we need to do is we have to subtract 180 minus 54 because the sum of the angles in a triangle equals to 180. So we're going to say 180 minus 54, right? And then we're going to divide it by 2. The reason why we're dividing it by 2, it's because we want to share our results with among these two angles, right? Because they are going to be equal. So we have 180 minus 54. It's going to give us 126 divided by 2. We divided by 2 because we have to share 126 equally among these two angles. And so that means that each one of them has to be 63. That means that x right here is 63. And this x right here is also going to be 63. So 63 plus 54 going to be equal to 180 degrees. And that's what we wanted it because angles, the sum of the interior angles in a triangle is 180 degrees. Now let's go on to y, right? Y. How are we going to find out the value of y? Well, y is going to be in this triangle right here. And here we are also dealing with another isosceles triangle. And how do we know that? Because this side and this side are equal. Now, how do we know that both sides are equal? Well, both sides are equal because notice the double dash here. These two lines indicate that these two sides are equal. And if these two sides are equal, that means we're dealing with an isosceles triangle, which means that if the sides are equal, the angles are also going to be equal. So that means that this angle and this angle, both of them are 72 degrees. And so we have 72 plus 72 and then y. And so what that means is that in order to find out what y is, we're going to add 72 plus 72 and we're going to subtract that sum from 180. And so we have 180 minus 72 plus 72, which is going to be 144. So we have 180 minus 144, which gives us 36. And so we have 72 plus 72 plus 36, which gives us 180 degrees. And that's how we know that our answer for y is correct. Let's move on to z. If we look at z right here, z is going to be the angle that is right here. This is z, okay? But if we notice carefully, we also know that this angle right here, which we just figured out, this angle right here, this angle is 72 degrees. We just figured that out because these two angles are equal. And then this angle right here is 63, isn't it? That's x, that's 63. And so what do we know? We know that this angle right here is 63. This angle right here is 72. We just have to figure what z is. And if we notice that these angles are at a common point and they are on a what? They're on a straight line. What do you know? What do we know about angles on a straight line at a common point? Angles on a straight line at a common point must add up to 180 degrees. So we have 63, 72. That means that whatever z is, it has to be such that when we add it with 63 and 72, the sum of those angles is 180 degrees. And so that means what we have to do is we have to add 63. We have to add 63 plus 72, and 63 plus 72 is going to be 135, and we're going to take 135 and subtract it from 180, which gives us 45. That means that z is going to be equal to 45. Okay, let's move on to the next question. Here we have a pie chart question. The question says a group of 24 tourists were asked which of the following islands they enjoyed the most. The results are shown in the table below. 10 tourists out of the 24 that was surveyed said that they enjoyed Exuma the most. Six said that they enjoyed Eleuthera the most. 5 said that they enjoyed Abaco the most. We do not know how many enjoyed Andros the most. The angle that is associated with the Exuma is going to be 150 degrees. The angle that is associated with the Eleuthera is going to be 90 degrees. And the angle that's associated with Andros, we do not know what that angle is. And the angle that's associated for Abaco and Andros, we don't know what those angles are. So what we need to do is we need to complete this chart. The first thing we need to do is figure out the number of tourists for Andros, right? The number of tourists that enjoyed Andros, right? So number of tourists for Andros, this should be for Andros instead of in Andros, right? The number of tourists for Andros, so let's move that. Number of tourists for Andros, okay? For Andros. So number of tourists for Andros is going to be definitely going to be 24 minus. So we're going to add up 10 and 6 and 5, right? 10, 6, and 5. And we're going to add them up and then subtract that sum from 24. So you have 24 minus 21, which is going to give us 3. So the number of tourists that enjoyed Andros the most is going to be 3. Okay, let's move on to the next question. We want to figure out the angle for Abaco. Well, how many tourists enjoyed Abaco the most? 5, right? 5 out of what? 24. So it's going to be 5 out of 24. And we're going to multiply it by 360. Why 360? Because the sum of the angles in a circle is going to be equal to 360 degrees. And so we have 5 over 24 multiplied by 360 degrees over 1. And so let's multiply them. 5 times 360 is going to be equal to what? 1,800. And 24 times 1 is going to be equal to 24. And so we have 1,800 divided by 24, and we get 75. And so the angle in the pie chart associated with Abaco is going to be 75 degrees. Let's move on to the angle for Andros. Well, the angle for Andros is going to be, in order for us to calculate that, we have to say 3 out of 24 because 3 persons enjoyed Andros the most. So 3 out of 24 multiplied by 360 over 1. We're going to say 3 times 360, which is going to be 1080. Then we're going to say 24 times 1, which is 24. We say 1080 divided by 24, which is going to give us 45. And so that means that the angle for Andros is definitely going to be 45 degrees. Okay, now we have a completed chart. So the completed chart is we have 10, 6, 5, and 3. And the angle in the pie chart is going to be 150 degrees, 90 degrees, 75 degrees, and 45 degrees. For this one, we already copied and completed the diagrams. We already did part A. For BI, we want to use a ruler and a compass and construct a circle with a 4 centimeter radius. All right. And then for BII, we want to draw an accurate pie chart to represent the information in the completed table. So what they want us to do is they want us to construct a circle with 4 centimeter radius. Then we want to draw an accurate pie chart, right? To represent the information in the completed table. So 115, 90 degrees, 75 degrees, 45 degrees, those are going to be the numbers that are going to be inside our pie chart. Okay, so let's go ahead and let's actually construct this. So we're going to get our construction tools to actually construct this particular pie chart. Remember that the angles that we want is 150, 90, 75, and 45. Okay, so here we have our construction tools. We're going to get our ruler. So let's get our ruler here. So we have our ruler here. And then we have to make sure that it's going to be what? But the ruler is going to be what? They say that they want a radius of 4 centimeters. A radius of 4 centimeters, all right? And so we have our ruler here, and it's going to be right here. And so we want a radius of 4 centimeters. So let's start right here. All right, and then we want a radius of 4 centimeters. We're going to start right here, and then we're going to go 4 centimeters. It's going to be right there. And so if we look carefully, right, that's 4 centimeters. And so let me zoom in. Okay, so it's 4 centimeters. And so that's going to be the length of our radius. But we have to construct a circle. And so we have to get our compass, and put it right here, right? And so that means that what's going to happen? We're going to draw a circle, right? Draw a circle. And this circle measures 4 centimeters in terms of its radius, okay? And so if you look carefully, our radius is 4 centimeters. Okay, so now we have a radius of 4 centimeters. Now we can go on and draw in the rest of the angles on this. So the angles on this, the first angle that we should draw, let's draw the 90-degree angle. So this right here is 0 degrees, and we have to draw the 90-degree angle. 90-degree angle is going to be up here. And so let's zoom in, make a point. All right, make a point to see where's the point. Okay, I need this. So we need to make a point 190. And so it's gonna be right, that's 90, right? And it's gonna be right here. Okay, so that's 90, right? And so what we need to do is so this right here is 90. So what we need to do is we need to go here and use a ruler. And when we get our ruler, we're going to adjust the ruler such that we can draw a straight line, right? From this point all the way to this point. So use a ruler and draw a straight line from this point to that point. Since I'm using technology, I'm just going to draw a line segment from this point to this point. Okay, so that's going to be based on my protractor, that's going to be what? 90 degrees. Okay, 90 degrees. Now that we have 90 degrees, for this one, we can erase the outside because you don't want to have that outside looking like that. Now let's label it. So you're gonna label this 90 degrees. So you're gonna draw a box to indicate that it's 90 degrees. It's gonna be 90 degrees. Okay. Okay, let's move on to the next question, the next part where we have to do 150 degrees. So we have to take our compass and move it here such that this side would be our base, right? This side would be our base. And so we're gonna count inside. We're gonna use the numbers on the inside of the protractor. So we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. And so here we're gonna indicate 150, right? So this right there is 150. We're gonna indicate 150, all right? Indicate 150 right down, all right? So 150, this right here is 150 degrees right down, okay? And so for you, what you have to do is you have to use your ruler, get your ruler, and we're gonna draw a line, right? We're gonna draw a line from the center, right? We're gonna draw a line from the center all the way to our point. Right? Draw a line from your center all the way to the point. But I am using technology, so I'm gonna use a line segment here just to make sure everything is accurate. But you want to use your ruler to draw this line. And so let's measure it. So let's measure it. So this is what? 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, all the way to 150. And here we have, this is 150 degrees. Okay, let's move on to the next part. Here we have to label it. We're gonna label this 150 degrees. 150 degrees. We're gonna label that 150 degrees. Okay, the next angle that we want to draw is going to be 45 degrees. And so we're going to use this as our base. Okay, so we're going to use this one as our base right here. And we're going to draw, so this is our base, right? That's a 0. And we want to draw what? 45 degrees. 45 degrees. So this right there is 0. And we're going to draw 45 degrees. So 0, 10, 20, 30, 40. And right here is going to be 45. Right there is going to be 45. So let's put the point. So we have to be right there. So right about there is, so right about there is, no, I'm sorry, that's not 45. 45 is here. This is 45 right there. This right here is 40 actually. This is 40. And this right here is 45. This right here is 50. So 45 is going to be right here. So let's indicate that by this point. It's going to be 45. And so then since that's 45, since this is 45, what we're going to do is we're going to get our ruler. Okay, going to get our ruler. And we're going to draw a line. Draw a line from our point of our center. From our center to the point. So you're going to draw a line from the center to this particular point. Now, because I am using technology, I'm just going to do a line segment. But you want to do you want to use your ruler. So this right here inside of here is going to be what? This right here is going to be 45 degrees, right? So it is going to be 45 degrees. And the rest or the remaining is going to be 75 degrees because that's just the last one. And so that's going to be equal to 75 degrees. Now, if we were to measure it out, let's look carefully. This is 0, 10, 20, 30, 40, and it's going to be 45, right? And 50 is down. Okay, now what we need to do is we need to erase all of the extra lines on the outside, and we need to actually label this Exoma, Abaco, and so on. And so let's look at this diagram. Here we have 150, 90, 75, and 45. And then if we look carefully, we have it labeled. So Eleuthera is 90, Eleuthera is 90, Exoma is 150, Andrus is 45, and Abaco is 75 degrees. Okay, let's move on to the next question. It says, for question number 11, the rectangular playground design below. So the rectangular playground design shown below consists of a lawn and two equal semicircles of concrete. Using pi as 22/7 where necessary in this question, calculate the perimeter of the lawn. So you need to figure out the perimeter of the lawn. The perimeter, as I have already highlighted in red, it was not highlighted in red in the exam. I highlighted it in red inside there for you, but it was not highlighted in red inside of the exam. So this right here, this particular length is going to be what? That's going to be 20 meters. But we want the area of the, sorry, not the area, we want the perimeter of the lawn. So the perimeter is going to be the outskirts, right? So it's going to be this 20 meters, this part in red, this curved portion in red. It's going to be this length, right? The length of the lawn, and sorry, the length of this particular side. And it's going to be the curved portion, right? That's the perimeter, okay, of the lawn. Now, in order for us to figure this out, we have to add up all of the lengths of all of the sides. And so if you look, if you notice carefully, um, the perimeter of the lawn is going to be 20, right? 20. Why 20? 20 because this length is 20, okay? Plus another 20. Why another 20? Because this 20 is going to be for this side as well. So both sides are 20 meters. Then we have the curved portion. So we have the curved portion right here. The curved portion is going to be the curved portion of a semicircle. And this right here is the curved portion right here. It's going to be the curved portion of a semicircle. Now, what is the curved portion of a semicircle? We know the perimeter or the circumference of a full circle is 2 pi r. And if we want a circumference or the circle of a half of a circle or semicircle, we're going to divide by 2. And if we want to divide by 2, this 2 and this 2 are going to cancel out. And so we're going to left with just what? Pi r. Pi r. That's going to represent the perimeter or the curved portion of a semicircle. And so we have pi r to represent this curved portion. And then we have another pi r to represent this curved portion. Okay, let's move on to the next question. Not quite the next question, but the next step. Okay, so here what we have is we have the substitute. What is pi? Well, pi is going to be 22/7. Now, what is r? Well, r is the radius, and the radius, by definition, is half of the diameter, right? The radius is half of the diameter. And so if you look carefully, this right here is the radius. It's going to be half of the diameter. And the diameter is 14, right? The full thing is 14. Half of 14 is going to be 7. So R, right? R is going to be equal to 14 divided by 2, which is going to be 7. And so we have that the radius is 7. The radius is 7. Pi is 22/7, and the radius is 7. And pi, again, is 22/7, and the radius is 7. Okay, next up, what we're going to do, we're going to cancel. And so we have this 7 cancel with this 7, and this 7 cancel with this 7. And so we have 20 plus 22 plus 20 plus 22. And when we add them all up, we get 84 meters. 84 meters. Okay, let's move on to the next particular question. It says fencing is sold at $40.75 per meter. Again, fencing is sold at $40.75 per meter. Calculate the cost of fencing the lawn. We already know that the perimeter of the lawn is 84 meters. So, and we know that each meter of fencing costs $40.75. And so it's going to be 84 multiplied by $40.75, which is going to be $3,423. Again, the answer is $3,423. That's going to be the total cost of fencing the lawn. The next question the next question asks us for the area of the lawn. The area of the lawn. The area of the lawn is different from the perimeter. The perimeter shows the outline, the length of the area shows the distance around the object, right? That's the perimeter. perimeter shows the perimeter shows the distance around an object, right? But for the area deals with the space inside. Okay, so you want to figure like what is the area of the space? Like how many space? What is the space? What is the amount of space we have inside of the lawn? Not the length or that we have around the lawn, which is the perimeter, but we want the space. The space. We want to figure out how much space we have on the inside. Now, in order to do this, what we need to do is we need to first calculate the area of the entire rectangle. So if we could figure out the area of the rectangle of the entire rectangle, which I'm going to denote in green. So we're going to figure out the area of the entire rectangle. What is the area of the entire rectangle? We're going to do length times width. That's going to be this full total area right there, the area of the entire rectangle is going to be that, right? Now, if we want, that's going to be the area of the rectangle. Now, if we want to now after we figure out the area of the rectangle, what we're going to do is we're going to figure out next, we're going to figure out the area of the semicircular portions. So this portion right there, we're going to figure this area, right, out. Then we're going to also figure out this area out, right, the area of the semicircular part. All right, then after that, what we're going to do is we're going to remove the area of the semicircle part, we're going to remove it from the area of the rectangle, and we're going to be left with just what? The area of the lawn, which is the area in between, okay? So we have to pull out, or we're going to take away the area of the semicircular part from the area, the total area of the rectangle. And so let's do that. So here's our link. And so what we have here is we have the area of the rectangle, which is going to be the length of the rectangle. What is the length of the rectangle? The length of the rectangle is definitely going to be 20 meters. And what is the width of the rectangle? The width of the rectangle is going to be 14 meters. And so if we want to find the area of the rectangle, we have to multiply 14 times 20 or 20 times 14, which gives us 20 meters squared. Now we have to figure out the area of the concrete. Notice that we have two semicircles. Two semicircles equals one circle. So we have to figure out, in essence, the area of one circle, which is going to be pi r squared. Pi is 22 over 7, and r is going to be 7. And so we have 22 over 7, which is pi, r, which is 7. So we have 7 squared. So 22 over 7 multiplied by 7 squared, which is going to be 49. And so we have 22 over 7 multiplied by 49 over 1. We multiply 22 times 49, which is going to be 1,078. And we do 7 times 1, which is going to be 7. So 1,078 divided by 7 is going to be equal to 154 meters squared. Next, we have to figure out the area of the lawn. So we figure out the area of the concrete, which is going to be 154 meters squared, and we figure out the area of the rectangle, which is going to be 280 meters squared. Now to figure out the area of the lawn, we got to subtract the area of the rectangle and the area of the concrete, which is going to be 280 meters squared minus 154 meters squared, which is going to give us 126 meters squared. Let's move on to the next question. It says a class of 30 students were asked if they studied physics or French. The Venn diagram below show their responses. We have for P only, or physics only, we have 2x minus 3. For the intersection, we have 8. For F only, we have x. And for the students on the outside, we have four of them, right? On the outside of the union of P and F. The question says, how many students study neither physics nor French? The answer to this one is definitely going to be 4 students, because 4 students are on the outside of the circle, right? They're still in the universal set, which means that they're still in the class, but they are on the outside, which means that they study neither physics nor French, and that's 4 students. The next question says, calculate the value of x. In order to calculate the value of x, we need to construct an equation. The equation is going to be 2x minus 3, which is P only, plus 8, which is going to be the intersection, plus x, which is going to be F only, plus 4. All of that together have to be equal to the universal set. And so what we're going to do is we're going to group the x's and we're going to group the numbers. So we have 2x plus x minus 3 plus 8 plus 4 is equal to 30. And so we have 2x plus x, which is going to be equal to 3x. Let's do negative 3 plus 8, right? So 2x plus x, we write that down. Negative 3 plus 8 is going to be what? Positive 5 plus 4 is equal to 30. And we have 5 plus 9 is going to be 9. Sorry, 5 plus 4, which is going to be 9. Again, 5 plus 4 is going to be 9. And 2x plus x, or 2x plus 1x, because this we have an imaginary 1 here. Once we do not have once we do not see a coefficient for the variable, that means that the coefficient is 1. Right? Once you don't see a number in front of the variable, that means that the coefficient is 1. So 2x plus 1x is going to be equal to what? 3x. And so we have 3x plus 9. And 3x plus 9 is going to be equal to 30. Next, what we're going to do, we're going to send the 9 over the equal sign. And so we have 3x is equal to 30 minus 9, which is going to be equal to 21. So 3x is equal to 21. Divide both sides by 3. And so this cancels, and this cancels. So we get that x is equal to 21 divided by 3. And 21 divided by 3 is definitely going to be 7. So that means that x, if you want to calculate the value of x is 7. The next question says, use your value of x to calculate the number of students who study physics only. Well, the number of students who study physics only is going to be 2x minus 3. We know that x is 7, and so that means that we're going to multiply 2 times 7, which is going to be 14. And if you say 14 minus 3, and 14 minus 3 is definitely 11. Let's move on to the next question, question number 13. It says the diagram below shows triangle ABC, and we have angle CAB is going to be equal to 35 degrees. Here we're going to figure out the length of the side BC. So what we have here is good, because what we have here is we have this side, which is 7, and we have this side, which is 8. And this is a right angle triangle. And so all we need to do is figure out the hypotenuse, which I'm going to denote as C. And so if we have 2 sides already given, and we want to figure out the missing side, we can definitely use Pythagoras theorem. And Pythagoras theorem says C squared equals to A squared plus B squared, where C is the hypotenuse. So C is BC. C is the line that we're trying to find, right? That's the length of this side. Now, let's substitute. What is A? A is going to be 7, so we have 7 squared. What is B? B is going to be 8, so we have 8 squared. And so 7 squared is going to be equal to 49, and 8 squared is going to be equal to what? 64. When we add them together, 49 plus 64 is going to be equal to 113. Divide both sides by C. So I divide both sides, but I'm not divide both sides. Take the square root of both sides. So you have C squared is equal to 113. We have to take the square root of both sides. Why are we taking the square root of both sides? Because we want to get rid of the square on top. So the square, this square root cancel with this square. And so we are left with just C is equal to the square root of 113. What is the square root of 113? The square root of 113 is definitely going to be 10.63014,581. They want us to calculate it to 2 decimal places. And so if we look at 3, that's the set number in the second decimal place. We look at 0, we cannot round up, so we have to just keep it as is. It's going to be 10.63 centimeters. That's going to be the length of BC. Next, we have, again, we know that the length of BC is 10.63. We want to figure out the size of angle CBD. Now, what is B? Well, B is going to be, right? B is going to be equal to this angle. That's going to be angle B. And so we have CB. We have CBD. CBD. That's going to be this. That's going to be the angle that we're looking for. And so we're really looking at this particular triangle right there. Right? This particular triangle. And let's label it, right? So this is the right angle. So the side that's going to be opposite the right angle, we call it the hypotenuse. This right there is the hypotenuse, H. The side that's going to be opposite the angle that we're looking for is going to be the opposite angle. Call that O, right? Or OP. And the remaining side is going to be the adjacent, right? So the side opposite the right angle is going to be the hypotenuse. The side opposite the angle is going to be the opposite. and the last side, or the last remaining side, is the adjacent. And so let's write that down. Again, let's write that down properly. So let's raise our link. If we were to write that down properly, we have that this side is h, this side is the opposite, and that side is the adjacent. And so here we can use SOHCAHTOA. SOHCAHTOA tells us that sine is going to be equal to the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse, and tangent is the opposite divided by the adjacent. The good news is that for this one, we could use any of the three trig ratios to find our answer, and all of them will be correct because we have all three sides, right? We have the adjacent, we have the opposite, we have the adjacent, we have the hypotenuse. Sorry, we have the hypotenuse, we have the adjacent, we have the opposite. And so we could use any of the three. As for what is my preference, I'm going to use tangent. And the reason why I'm going to use tangent is because I want to use the opposite side and the adjacent side. The opposite side was given to us, the adjacent side was given to us. The hypotenuse we had to find. And so I don't want to use the value that we had defined and round. All right. So I'm not going to use sine and I'm not going to use cosine. I'm going to use the numbers that were given. Okay. So 7 centimeters and 8 centimeters, these were given. And so the opposite is going to be what? The opposite is 7 centimeters. What is the adjacent? The adjacent is 8 centimeters. And so tangent of theta is going to be the opposite, which is 7, and the adjacent, which is 8. What we're going to do is we're going to take tan inverse of both sides. We have tan inverse of tan theta is going to be equal to tan inverse of 7 over 8. What we're going to do is we're going to cancel this tan inverse with tan. And so we're going to be left with theta is equal to tan inverse of 7 over 8. Put that inside the calculator as is, and we get theta is going to be equal to 41.18592517 degrees. And since we wanted the 2 decimal places, what we're going to do is we're going to look at underlying 8. We're going to circle 5. Okay. 5, once it's 5 or greater, we could add 1. So we're going to add 1 to 8. And so it's going to be 41.19 because we add 1 to the 8. And so theta or angle B or angle CBD is going to be equal to 41.19 degrees. Again, 41.19 degrees. Let's move on to the next question. Here, we want to figure out the length of the side AB. Now, let me just highlight that for you, the length of the side AB. AB is going to start from here and go all the way here. That's the length of the side AB, okay? AB. Now, the thing is that we know what BD is already. If we could figure out what DA is, or if we could figure out what AD is, then what we could do is we could, once we figure this out, we could add this number with this number to get the length of the side AB, okay? Now, so let's try to determine what is the length of this side, DA, because if we get the length of DA, then we could add length DA to BD, and then we could get the total length, right? All right, so let's continue. So we have what we have here is that this right here is going to be the opposite. So I'm sorry, this right here is going to be the hypotenuse because it's opposite the right angle. This right here is going to be what? The opposite, okay? Because it's going to be opposite the given angle, and the remaining one is going to be the adjacent. And so if we want to figure out which trig ratio to use, because we're trying to figure out the adjacent, let's look at our trig ratios. Look carefully at your trig ratios. We have sine, cosine, and tangent. We have to use a particular trig ratio that has the adjacent side. Why do we have to use one that has the adjacent side? We have to use the one that has the adjacent side because we are trying to find DA. We're trying to find DA. So we need to figure out what is the length of the adjacent side. We can find the adjacent by using tan theta, and we can find the adjacent by using cosine. But the problem is we cannot use cosine because we don't know what the hypotenuse is. And so we are forced to deal with tangent again because we know what the opposite is. The opposite is 7 centimeters. And so let's go ahead and um, perform the calculations. So we have that tan of theta is going to be equal to opposite divided by the adjacent. What is the opposite inside of this question? Again, what is the opposite? Well, the opposite is definitely 7 centimeters. That's the opposite, 7 centimeters. What's the adjacent? But we don't know what the adjacent is. Okay, we don't know what the adjacent is. And so the opposite is 7. The adjacent is, but we don't know what the adjacent is, so we put x. And we have tan 30. Why do I have tan 30? It's supposed to be tan 45, tan 35. Why tan 35? It's tan 35 because this angle right here is 35. So what I'm going to do, I'm going to correct this, and then I'm going to come back and resume the recording. So here we have tan 35 and not tan 30, tan 35. So tan 35 here. And we have 7, which is the opposite over the adjacent, which is x. We don't know what the adjacent is, so we call it x. I'm just going to cross multiply. And that's why I put tan over 1 because I want to cross multiply. So we're going to multiply this x with tan 35. We're going to multiply the 1 by the 7. We already know that 1 times 7 is definitely 7, and x times tan 35 is x tan 35. We want to isolate the x, so that means that we want x by itself. So we're going to divide both sides by tan 35. And so that way we can cancel this tan 35 with that tan 35. And we get that x is equal to 7 divided by tan 35. What is 7 divided by tan 35? That's going to be 9.99703604.7. That's going to be x, which is going to be the length dA, right? But we don't just want the length dA, right? We want the length AB. And so let's add them together. So AD, right? AD, I have AD or DA, right? AD or DA is going to be equal to 9.99703604.7. That's the length of AD. Now, in order for us to figure out the length of AB, we're going to say AD, which is this one, plus DB, and then we can add it to 8. So AD is going to be equal to 9.99703604.7 plus 8 centimeters. When we add them together, we get 17.99703605. But we wanted the 2 decimal places. And this is interesting because if we write this to 2 decimal places, notice carefully, right? Notice carefully that we have 7, right? So we have a 7. And so this number right here, we have to add 1 to it. Okay, so we have to add 1 to it. Now, if we add 1 to it, right, what's going to happen? Well, if we add 1, this is going to turn into a 0, right? And we add 1 here, right? If we add 1 here, this is also going to be what? Turn into a 0 as well. And so we're going to add 1 again. And then this is going to be 18. So it's going to be 18.00. Okay. And so let me erase our link. So basically, 17.99703605 written to correct the 2 decimal places is going to be equal to 18.00 centimeters. Okay, let's move on to the next question. Here we have a probability question. It says operators of a game show are setting up a color spin wheel for prizes. There are 18 segments on the wheel, and each segment has an equal chance of stopping on the arrow. Determine the probability of getting G. But in order to figure out the probability of getting G, we have to figure out like how many G's do we have? So we have 1 G, we have 2, we have 3, we have 4. We only have 4 G's that I can tell. Let's try it again. 1 G, 1, 2, 3, 4. So it's going to be 4 all over 18. Why 18? Because 18 is going to be the amount, the total amount of segments that we have. So 4 out of 18. 4 because it's 4 G's, and 18 because that's the total amount. Now we can divide both sides by 2. 4 divided by 2 is 2, and 18 divided by 2 is 9. So the answer is 2 9s. Let's move on to the next question. We're going to figure out the probability of getting a B or R. How many B's do we have? Okay, this is 1b. This is 2b, 3b, 4b. Okay, 5b's. Okay, so we have 5b's over 18. Okay, is that b? Okay, I said 5. I counted 5. Let me count that again, because here I have 4 for some reason. So the first one was G, and so I don't know why I have 4 here. Let's do it. Let me count it again. Let me count it again to make sure everything is right. So we have how many? We want to figure out the B's first. So B's, so this is 1B. This is, let's go, look. This is 2B's, 3B's, 4B's. It's gonna be what? 5B's. 5B's. And so what that means is that I have to correct this, so this is not right. So the answer is gonna be what? 4 over what? Not 4. It's gonna be 5 over 18, not 4. So it's gonna be 5 over 18. So we have 5 over 18. 5 over 18 plus 5 over 18 plus what? We want to figure out red, the probability of getting red. So let's do that. Probability of getting red. So 5 over 18 plus the probability of getting red. Where's red is going to be? How many does red have? Looking for red. Red has 1. Red has 2. Red has 3. Okay. Red has 3. Okay, red has 3. So it's going to be 3 over 18. Okay, 3 over 18. So 5 over 18 and 3 over 18. Okay, good. What is 5 over 18 plus 3 over 18? 5 plus 3 is going to be what? 8. 8 over 18. 8 over 18. And then we could simplify that. We could divide the top by 2 and the bottom by 2. What is 18 divided by 2? Sorry, what is 8 divided by 2? Well, 8 divided by 2 is definitely 8 divided by 2 is definitely 4. And 18 divided by 2 is definitely 9. All right? And so what we have here is we have 4 over 9. 4 over 9. And 4 over 9 is the same thing as 8 over 18. Can we simplify further? 4 and 9? The answer is no. Let's move on to the next question. Okay, so the correct answer is not 7 over 18, it's 4 over 9. Okay, let's move on to the next question. So the next question says, there are 18 segments on the wheel and each segment has equal chance of stopping on the arrow. Which colors has 1/6 chance of occurring? So the colors that have 1/6 chance of occurring, let's look at red. So the probability of red is going to be what? 3 out of 18. Why 3 out of 18? Because there are 3 reds out of 18 segments. And if you simplify these two, divide top and bottom by 3, we get 3 divided by 3, which is 1, and 18 divided by 3, which is going to be 6. And so red is a color that have a chance of, that has a 6 chance of occurring. Let's look at purple. Purple, P is for purple, right? So how many purples do we have? We have 3 purples. So it's going to be 3 divided by both top and bottom. So 3 over 18, and then 3 to simplify it. 3 divided by 3 is definitely 1, and 18 divided by 3 is definitely 6. And so the colors which have a 1/6 chance of occurring is red and purple. Let's move on to the next question. It says, which color must the white segment be painted for the 3 colors to have an equal chance, of occurring? Which color must the white segment be painted? So if we had to paint the white a particular color, right? What color must it be painted so that 3 colors will have an equal chance of occurring? And the answer is the white segment must be painted yellow for the 3 colors to have an equal chance. Now, why yellow? So let's say, for example, right? Let's say that this W or this white was painted yellow. That means that we'll have 1 yellow. This is 1 yellow, right? That means we'd have 2 yellows. There's another yellow here, right? So 2 yellows, right? And that means we have what? We'll have what? 3 yellows. Okay, we have 3 yellows. It's going to be 3 yellows. And if we have 3 yellows, then what does that mean? Well, that means a lot. That means that the probability for yellow is going to be 3 over 18. And that's going to mean that if we simplify, this is going to be 1 over 6. So that means that the probability of yellow would be 1 over 6. And so just like red, just like purple, yellow would also have a 6 chance. So all of them would have an equal chance. All 3 segments would have an equal chance of occurring. Okay, if white was painted yellow. Okay, let's move on to the next question. It says, if the wheel has spun 56 times, how many times would you expect blue to occur? The first thing that we need to do is we need to figure out the probability of B, or probability of blue. So blue is going to be what? 5 out of 18. 5 out of 18 because let's do blue again. 1 for blue, 2, 3, 4, and then 5 for blue. So the probability of the probability of blue is going to be 5 over 18. But they say, how many times would you expect blue to occur if it's spun 36 times? Remember, each time it has a 5 over 18 chance of occurring. So each of the 36 times. So we multiply 5 times 36. So that we have 5 over 18 multiplied by 36 over 1. 5 times 36 is 180. 18 times 1 is 18. And so we get 18 divided by 180. Sorry, we have 5 times 36, which is going to be 180. And we have 18 times 1, which is going to be 18. And 180 divided by 18 is going to be 10. Let's move on to the next question. Here we have a graphing question. And they said, copy and complete the table of values for y is equal to x plus 1. Y is equal to 9 over x plus 1. Okay, so when the x value is 0, the y value is 9. When the x value is 0.5, the y value is 6. When the x value is 1, the y value is 4.5. When the x value is 2, we don't know what it is. Now, I already have 3 here because I actually calculated it. But before the question was calculated or solved, before I put the answer, this was actually blank, all right? So we do not know what this number is yet. Let's just pretend we don't know it yet. Even though we already calculated, let's pretend that this 3 was not here. So neither the 1.5. So the 3 and the 1.5 was not here initially, right? We got those numbers by calculating it. And that's what I want to show you, how I got the 3 and how I got the 1.5. Okay, so we know that x is equal to 2, right? According to this. Now I'm going to take this equation, and then wherever I see x, I'm going to put 2. So we have y is equal to 9 over x plus 1. Again, wherever I see x, I'm going to put 2. Then we have 9 divided by 2 plus 1. 2 plus 1 is 3, and so we have 9 divided by 3, which is 3, because 3 times 3 is 9. And so that's how we get the 3 here for this one. Now we have x is equal to 5. So when x is equal to 5, what is the value of y? Well, wherever we see x, we're going to put 1.5. We're going to put 5. So 9 over, again, here's x. So we're going to put 5. 5 plus 1. So we have 9 over 6. And then we have 9 over 6 is going to be equal to 1.5. And so the answer there is 1.5. So that's how we got the 1.5. And that's how we got the 3. The next question tells us what we want to do. They want us to plot it. So using a scale of 2 centimeters to 1 unit on both axes, taking x values from 0 to 8 and y values from 0 to 9, draw and label the graph of y is equal to 9 over x plus 1. That is B. That's what they want us to do. They want us actually to draw and label this particular graph. The first thing we need to do is we need to deal with our x-axis and our y-axis. X-axis goes from 0 to 8. But it's very important to note that we're going from 2 centimeters equal 1 unit. That means that we're counting in, that means that we're going to move over 2 blocks, and each 2 blocks is going to be 1 unit. And that's for both sides, both the y and the x. The y goes from 0 to 9. The x goes from 0 to 8, which means that we have no negative values. So let's go here. So we're going to go from 0 to 8 on the x-axis, and then on the y-axis, we're going to go from 0 to 9. Notice that we go 1, 2, and that's our first unit. Then we go 1, 2, that's our second unit. Then we go 1, 2, that's our third unit. And we continue that straight on because it says 2 centimeters equal to 1 unit. Okay? Same thing for our y-axis. We go 1, 2, that's 1 unit. Then we go 1, 2, that's another unit. Then we go 1, 2, that's another unit. Then we go 1, 2, that's another unit. So we have to skip 2 blocks to get our units. So let's actually plot these points. So the first point we're plotting is 0, 0, 0, 9, 0, 9. So 0, 9 is we have 0 here on the x-axis, and we have a 9 here, right now. So that's 0, 9. Then we have the point 0.56. Now 0.56, if this is 0 and this is 1, let's zoom in, right? We want 0.5. So this right here is going to be 0. There's going to be 0.1, 0.2, 0.3, 0.4, 0.5. And so that's why we have here, this is 0.56, right? 0.56. Next up, we have 1 and 4.5. 1 and 4.5. 4.5 is right here. Then we have 2 and 3. 2, 3 is going to be right here. Then we have, what else? We have 3 and 2.3. So this is, let's look carefully. Let's look carefully. Let me start this over. Let's go over to the other side. Okay, so we have 3 and 2.3. This is 2. This is 2.1, 2.2, 2.3. Okay. All right, good. So 2 and 2.3, 3 and 2.3 right here. Then we have 4 and 1.8. 4 and 1.8. This is going to be 1. This is 1.5. If you look carefully, this is 1. This is 1.5. This is 1.6, 1.7, 1.8. Okay, that's 1.8 right there. So we got 4 and 1.8. Then we got 5 and 1.5. So 5 and 1.5. This right here is 5. And then this right here is 5. And then we got 5 and 1.5, which is here. We already did 4 and 1.8. But 5 and 1.5. If you look carefully, right? Notice, right? Notice that. Let's go over. Notice that. Let me show you. This right here is 1.5. Okay. This line right there is 1.5. And so if we look carefully, when we go over, this is going to go what? 1.5. So 5 and 1.5. The next one is 5 and 1.5. Next one is 6 and 1.3. 6 and 1.3. What is 6 and 1.3? 6 and 1.3 is going to be, if this is 1, right? If this is 1, right? Then we need 1.3. 1 and then 1.3. Okay, this is 1, 1.2, and 1.3. This is off, isn't it? 6 and 1.3. Let's look carefully at 6 and 1.3. I might have to redraw this if that's off. So if it's off, then I have to redraw the point. So let's do it again. So we have 6. This is 1, right? If we go over carefully, let's look at it. That's 1. Okay. This is 1. We want 1.3. This is 6, 1.2, 1.3 actually supposed to be here. I have it at 1.4 for some reason. There's 1. Let me look at it. This is 6. Sorry, this is 1. 1. Oh, I'm sorry. I am so sorry. This is right. This is 1. This is 1.2. Oh, no, I'm sorry. This is 1, 1.1, 1.2, 1.3, 1.4, 1.5. Okay, so we do have it right. Let me just show you. But this line right there is 1. This line right there is 1. So I'm going to keep that here so you can see it. This line right there is 1. We go over, we're still on 1, right? So this is 1. Up a notch is 1.1. Up another notch is 1.2, and here is 1.3. Okay. And then we have 7 and 1.1. 7 and 1.1. That's going to be 7. This is 1. This is 1.1. Right, 1.1. And then here we have 8 and 1. We have 8 and 1. 8 and 1 is going to be right there. This is 8 and 1 right there. Now, I actually supposed to continue this line. And so what I'm going to do is I'm going to continue this line. All right, so I'm going to draw it in. So what you have to do in order to like have it all in, what you have to do is you have to start up top and draw a smooth curve. So you're going to draw a smooth curve. Okay, let me go back to here. You're going to draw a smooth curve. So just draw the smooth curve. So you're going to draw a smooth curve. So the smooth curve is going to come from here. Just keep it steady. Make sure that your points line up exactly with, let me erase it so we could, so you could see it. So we're gonna start here and we're gonna make sure that all our points are there. So we gotta do the 0.56. We gotta do all of this. We gotta do all of that. Make sure all of the points, are covered. All of the points are covered. Okay. And the one that I missed was this one. This is the one that I missed. Okay. And so it's gonna look something like this. And so let me erase our link. So when you do it, you're gonna get a line and connect this. But this one I just have to connect this one right there. Okay. And this one it's too big. So for you, you're gonna use a pencil and just gonna connect it. In fact, let me show that. I'm gonna pause the video and correct it so you can see what I'm talking about. Okay, so I was able to correct it, and as you can see, the 8 and the 1 is connected with the rest of the points. All right, so you're gonna draw a smooth curve connecting all of the points, as shown. All right, okay, good. So that's how we have it. All right. I have the labeling right here, y is equal to 9 over x plus 1. That's the name of the graph. That's the name of this curve, right? Y is equal to 9 over x plus 1. And y is equal to 7 minus 2x is going to be the name of the lineup you're going to draw very soon. Okay, so let's move on to the next slide. It says, on the same graph, draw and label the graph of y is equal to 7 minus 2x, and then write the coordinates of the point of intersection. So let's go ahead and do that. So they want us to draw this graph. It's going to be y is equal to 7 minus 2x. This line is easy to draw because they give us the y-intercept. The y-intercept is 7. So that means that we're going to start at 7. Okay. And they tell us that the slope is negative 2. Negative 2. Because you know that the slope is negative 2 because, well, the slope is always the number. The slope is always the number that's in front of the x. So the number that's in front of the x is going to be 2. So our slope, or our gradient, we can call it m, is going to be equal to negative 2, right? Negative 2, and put it over 1, which tells us since our slope is negative, that means that your graph is going to go like this. If it was positive, then it's going to go like this. But since it's negative, that means it's going to be descending. And so it's going to be going down like this. And so let's go ahead and draw this graph, right? So if we're going to draw this graph, what we're going to do is we're going to start at 7 and we're going to go down. All right. Now, remember, rise over run. Rise. So the 2 tells us that we can go up or down on the y-axis. And the 1 tells us that we only could go one space across. Okay? This is rise over run. So again, 2, we only could go 2 spaces up or down. And the 1 tells us we only could go one space left or right. Okay? Again, 2 spaces up or down, 1 space left or right. But the negative tells us that the orientation of the graph. It tells us the direction of the graph, which way it's going. So we're going to start at 7. This is going to be our first point. Start at 7, and then we're going to go what? We can go 2 spaces down. So it's going to be 1, 2, and then we're going to go one space across. So it's going to be right here. So I'm sorry. I did this wrong. 2 spaces down. That's going to be 1, 2, and then 1 space across. 1. I hope you all see that. Let me do it again. 2 spaces down, it's going to be what? Let me use a different pen. So 2 spaces down, So we're gonna do 2 spaces down and then 1 space across. So two spaces down is gonna be 1, then 2, and then 1 space across is going to be 1. Now let's do it again. 2 spaces down, 1, 2, and then 1 space across, gonna be 1. 2 spaces down is gonna be 1, 2, and then 1 space across is gonna be 1. 2 spaces down, 1, 2, and 1 space across is gonna be 1. And notice at each point we're reaching on to a new another point on the graph. Again, 2 spaces down, 1, 2, and then 1 space across, 1. This is another point on the graph. Okay, 2 spaces down, 1, 2, and then 1 space across, 1. And so that tells us the slope of the graph, how we're gonna maneuver, right? Or you can go 1 space across, 2 space up, 1, 2. 1 space across, 2 space up, 1, 2. This is another point. 1 space across, 2 space up, 1, 2. Okay, or you can go 2 spaces down, 1, 2, and 1 space across, 1. All right, that's the slope. The slope is -1. And so if we connect all the points that we got and draw a line, we'll get this line y is equal to -2x. And so let me erase all link. So we get this line y is equal to -2x. Y is equal to y is equal to 7 minus 2x. Okay, that's going to be the line that we have. Y is equal to 7 minus 2x. And so this is the purple line. The point where they intersect is going to be 0.56, and it's going to be at 2, 3. So that's going to be the point of intersection, 0.56 and 2, 3. Okay, let's move on to, this is it represented on a, this is it represented again, but this is a computer generated graph. As you can see, the point of intersection are the same as we found. Okay, the next question is a transformation question. It says using 1 centimeter to 1 unit on both axes. So for the x-axis, we're going to go from -6 to 10. So let's go to that. That's going to be -6 to what? 10. And then on the y-axis, we're going to go from -8 to 12. And so we're going to go from -8 all the way at the bottom to +12. All right. Okay, good. So we're going to go from -6 to 10 and then -8 to 12. Copy and label the quadrilateral ABC shown below. So we have to basically copy and we have to redraw this quadrilateral on our graph. And here the points are 1, 1, that's D, 1, 1, 3, that's A, 2, 1, that's C, and then 3, 4, that's B. And so this is the quadrilateral that we have. The next question says that we want to reflect ABC, A, B, C, D in the line y is equal to -2, and then we want to label it A1, B1, C1, and D1. And so we have to perform a reflection. So the reflection in the line y is equal to what? -2. The line y is equal to -2. Do I have that labeled? I'm sorry. The line y is equal to -2 should be labeled out. So let me label it. We have the line y is equal to -2. That's the line right there. Y is equal to -2. This right here is the line y is equal to -2. And how do we know that's that line? Because it's a horizontal line passing through -2. And that's what y is equal to -2 means. You're going to draw a horizontal line passing through -2 on the y-axis. Now, we are going to perform the reflection. Now, how are we going to do the reflection? If you notice carefully, right? If you notice carefully, let's look carefully. Let's start at this particular point. And if you look at this particular point, we're going to go 1, 2, 3 spaces, which means that our other point, our reflected point, is going to be 3 spaces from this line. It's going to be 1, 2, 3. And so that's where that point is. Now let's go on to the next point, or let's go to the next one. Let me zoom in so you can see. So we're going to move over how many times? We're going to move over, let's look carefully. We're going to move over. We have 1, right? 2, 3. Okay, so we move over 3 times, right? to get to this particular line. Now we're going to move it 3 times again. It's going to be 1, 2, and 3. Okay, and so that's how we get D1 and C1. Okay, and we're going to use the same action to get the rest of them. So let me erase this, file drawings, and let's go here. So what we're going to do is we're going to do the same thing to get A. So A is going to be 1, 2, 3, 4, 5. So because we move 5 spaces to get to the line of reflection, we're going to move 5 spaces again. It's going to be 1, 2, 3, 4, 5. So A1 is going to be 5 spaces below. And then now we have B. B is going to be what? 1, 2, 3, 4, 5, 6. So you're going to move 6 spaces below. 1, 2, 3, 4, 5, and 6. And so B1 is going to be right here. And so that's how we perform the reflection using this particular line of reflection, which is y, the line y. Let's write it again. The line y is equal to -2. Okay, let's move on to the next question. Next question says that we want to, let's go on to the next question. Next question says that we want to enlarge ABCD using scale factor of 3, an origin and the origin as a center. Label the enlargement AB, A2, B2, C2, and D2. And so for this one, we have to enlarge ABCD using the scale factor of 3. So let's enlarge it. So if we enlarge it, remember enlargement means we have to multiply each coordinates by 3. So the scale factor is 3. So if we enlarge this, we have to multiply by 3. 1 times 3 is 3. 3 times 3 is 9. So A2 is 39. Then we have this one. B is 3, 4. Okay, the point B is 3, 4. And so that means that if we want to enlarge it, we're gonna multiply that by 3. And so we multiplying that by 3, we're gonna say multiply this by 3. So B2 is gonna be 3 times 3, which is going to be 9. And then 4 times 3, which is gonna be 12. So B2 is 9, 12. And then we have it's 2, 1. C is 2, 1. So we're gonna multiply that by 3. 2 times 3 is going to be 6. And 1 times 3 is going to be 3. So C2 is 6, 3. And then we have D1. D which is 1, 1. Well, D which is 1, 1. So we're going to take 1 multiplied by 3, which gives us 3. And we're going to take 1 multiplied by 3, which gives us 3. And so our coordinates are A2 is 3, 9, B2 is 9, 12, C2 is 6, 3, and D2 is 3, 3. And so we're going to plot those points. A2 is 3, 9. B2 is 9, 12, right? 9, 12. So you can see the 12 over here, 9, 12, right? 9, 12. And then we have C2. C2 is 6, 3. C2 is 6, 3. And then we have D2. D2 is 3, 3. D2 is 3, 3. And so that means that that's the enlargement right now. Notice for the enlargement, it got bigger, right? It got bigger. Okay, let's move on to the next question. And we know that the center of enlargement is the origin because if you notice carefully, this line intersects with A. This line intersects with B and B2. This line right here intersects with D2 and D. And this line intersects with C and C2. And all of them meet at the origin. So we know that the center of enlargement here is the origin. Okay, let's move on to the next one. It says translate A, B, C, D using the vector -4, 5. Label the transformation A3, B3, C3, and D3. Okay, let's do this. So we have to translate. So we have to use the vector. So what we have to do is we're gonna go for each point and we have to use the vector. The vector they said us to use again. -5, 4. So we have to use that vector. -5, 4. And so the vector -5, 4. We have to add that to each point. So it's going to be 1, 3, 3, 4, 2, 1, and 1, 1. So 1, 3 plus 5, negative 5, 4. We're going to say 1 plus negative 5. 1 plus negative 5 is going to be negative 4. 3 plus 4 is going to be what? 7. And then eighth, and then B3. B3, we have 3, 4. We add that to negative 5, 4. 3 plus negative 5 is going to be what? 3 plus negative 5 is going to be negative 2. And 4 plus 4 is 8. So our new point is negative 2, 8. Then we have C3. C3 is 2, 2, 1. We're going to add that to negative 5 and 4. And we get that 2 plus negative 5 is negative 3. And 1 plus 4 is 5. And then for D3, we have 1, 1. We're going to add that to negative 5 and 4. 1 plus negative 5 is going to be negative 4. And 1 plus 4 is going to be positive 5. And so it's going to be negative 4 and 5. And so we have A3, B3, C3, and D3. Okay, so let's plot these points. So A is going to be, A3, sorry, is going to be what? Negative 4 and 7. That's just there. B3 is going to be negative 2 and 8. C3 is going to be negative 3 and 5, right there. And then D3 is going to be negative 4 and 5, which is right there. So basically, we're taking this point, move it over 5 times. So it's going to be 1, 2, 3, 4, 5. And then we're going to add it up 4 times. It's going to be 1, 2, 3, 4. And that's why they said that the vector for the transformation is negative 5, 4, because we move over to the left 5 times and we move up 4 times. Okay, let's move on to the next question. A transformation maps A, B, C, D onto A4, B4, C4, D4, such that A4 is negative 1, negative 3, B4 is negative 3, negative 4, C4 is negative 2, negative 1, and D4 is negative 1, negative 1. Plot and label A4, B4, C4, and D4. If we plot it, we have to plot these points. It's going to be negative 1 and 1. Then we're going to have negative 2 and negative 1, right? And then we're going to have negative 3 and negative 4. And then we're going to plot negative 1 and negative 3, and negative 1 and negative 1. So when we plot all them, this is what we get. And what they want us to figure out is they want us to figure out like what is the single transformation that's, you know, maps A, B, C, D onto A4, B4, C4, and D4. Now, the transformation, if you notice carefully, right? If you notice carefully, this right here is a rotation. And it is a rotation because if you look carefully, notice that we rotated it. We rotated this object like so. All right, so we rotated. It was a 180-degree rotation. Okay. Either clockwise or anti-clockwise. And so that's what we can determine just by looking at it. It's a rotation of 180 degrees. But if we want to be specific, we can actually show that it's a 180-degree rotation because we have actually a formula. So the formula for 180-degree rotation about the origin, clockwise or anti-clockwise, tells us that if the pre-image, the coordinates of the pre-image is x, y, then the coordinates of the image is going to be negative x, negative y, which basically means that whatever your x and y coordinates are, just negate them. And if we look at our the coordinates of our pre-image, the coordinates of our pre-image was 8, 1, 3, right? Which the coordinates of A4 is negative 1, negative 3, so we negate them. If we look at the coordinates of the pre-image, it's going to be 3, 4, and for B4, it's negative 3, negative 4, so just negate them. Same thing for C, the coordinates are 2, 1, and then for the coordinates of the image, it's going to be negative 2, negative 1, and then the same thing for D4. Same thing for the coordinates of D. The coordinates of the pre-image is 1, 1, and the coordinates of the image is going to be negative 1 and negative 1. Okay, and so that means that this is definitely rotation clockwise or counterclockwise of 180 degrees about the origin. And so if we were to describe that, we'd say rotation of 180 degrees clockwise about the origin. That's the single transformation that's a description of a single transformation that maps A, B, C, D to A1 to A4, B4, C4, and D4. Okay, that brings us to the end of this lesson. Thank you for watching this video, and I'll see you in the next video.